In Part 3 of Lecture 7, we will discuss LR1 and LALR1 parsing. SLR1 grammars are limited to some extent in terms of the languages that they can process. Having a look-ahead built into the various items becomes extremely useful. As before, we start with the special start symbol S deriving the regular start symbol E, followed by the end of file marker. Since we have included the end of file marker in this initial item, there is literally nothing coming after this item. And with the dot immediately preceding the non-terminal E, we will need initial items for E. And we will add their look-ahead sets into the items. We have the two initial items for E. In the items present at this point, the non-terminal E is followed by the end of file marker in production 1 and the plus sign in production 2. So this follow set will appear in the items for E. Since we have the dot immediately before the T, we now need initial items for T. In two cases, the T is at the end of the right sentential form. So we will add the follow set of E to the follow set for T. In the third case, the T is followed by an asterisk. So we add this as well. Since this includes T derives .f, I will need initial items for F as well. Since F's only appearances on the right-hand side are at the end, I will need to include T's follow set. And in this way, I now have state 0 for the LR1 state machine. As we derive the states one transition away from state 0, we see that the follow sets remain the same transition after transition. The only instance that is different is state 6. In this case, the item F derives dot open parenthesis E close parenthesis has a different follow set at the bottom because this is not a factor at the beginning of the entire expression. It is a factor immediately after the open parenthesis, and we don't expect to find the end of file marker in this case. We expect to find the close parenthesis. Here we can see the 5 states to which we transition from state 6, depending on the symbol that we have next. Please note that state 15 is almost identical to state 6, except for the look-ahead set in the item at the very top. This difference shows up in the other states as well. Here we can see half of the LR1 state machine. As you might expect, it is far larger than the SLR1 state machine, because the differences in the look-ahead sets requires a larger number of states. Several of the states in this half of the state machine differ from some of the states in the other half of the state machine only in their look-ahead sets. The larger state machine leads to a larger parse table. It is not surprising that we have a large number of blank boxes that indicate that there will be no action or goto if we are holding this look-ahead token while in this state. If we were holding that look-ahead, it would indicate an error in parsing. In compilers for commercially oriented programming languages, these parse tables can be quite huge, with a very large number of empty sets. This leads to effort to compress the table, so it can take up less space in memory. Given how big LR1 parse tables can be, we have a strong incentive for simplifying them. And the easiest way to do that is to see if we can merge any of the states in the LR1 state machine. It turns out that we can do this, and we get something very similar to the SLR1 state machine. If we combine states whose items match in every way other than the follow sets, we can compress our state machine from 23 states down to 13. The only states that remain as they were are state 0, where we started, state 1, where we are looking for the end of file marker, and state 22, the acceptance state. This brings us to the LALR state machine. It pretty much looks like our SLR1 state machine, except it includes the follow sets. We may not always see such a strong resemblance in other instances where we create an SLR1 and an LALR1 state machine.